My name is Lexi Kessler. I'm a research technician and a former grad student here at the University of Delaware. I did my master's here on soil-borne diseases and plant parasitic nematodes within soybeans, very specifically soybean cyst nematodes, very specifically in this field. A little bit later, I'll be talking about a nematode survey I did for about 3 years during that same time, just talking about the different types of nematodes here. Within this field, this is our naturally inoculated soybean cyst nematode field. It has incredibly high populations, and for research, it's a good thing. But we're not here for nematodes, I'm assuming nematodes are a bad thing. And I'm going to talk a little bit about their life cycles today, but most importantly, I'm going to talk about resistance and things that you can use to combat nematodes. The biggest thing right now that you can use are different resistance sources. So the major resistance source in commercial varieties that we use today is called Plant Introduction Line 88788, or PI 88788. It is the most common commercial line, and it has one resistance gene, only one source of resistance. Unfortunately, for the past decade or so, we've been seeing reproduction levels on plants with this resistance source skyrocketing. So for example, in this field on one of our plants with PI 88788, we're seeing reproduction levels at 66%. So that means 66% of the females attached to that root are viable and can produce eggs. Females look a lot like this. They're these little yellow-shaped kind of nodules. They're a lot smaller than nodules. When they're alive, they're yellow. As they start to die off, they become cysts. These cysts are survival structures, and inside these females and cysts can be up to 250 eggs. When these are viable, these can actually overwinter in your soil for, I think I've read up to about 10 years, which makes crop rotation very, very tricky. And that makes resistance sources even more important. So one of the things that we have been trying is using other resistance sources. Now, unfortunately, the available resistance sources that we can get our hands on are not in maturity groups here. So you'll look at some of these beans, you've noticed they're drying down a little bit faster than some of the others. These are primarily out of the Midwest. These are called Peking and PI89. I just want to make sure I get this right. PI 89772. So the PI 89772, that's in a maturity of 2.3, and the Peking is in a 2.6. But what we can do and what we have done is compared nematode females on roots and done soil samples at planting and at 30 days after planting. So the other thing I wanted to talk to you about today, we've talked about resistance sources. If you have any questions about how our trial is done, I did a small PDMR on it last year, so I can give you some information on how well it did. I'm going to cut to the chase. It didn't do great. We didn't see a whole lot of differences among resistance sources. That could just be because we have very high populations here. But this year should be a little bit more telling. This will be the second year that we've done it. A way that you can check for these females is at 30 days after planting. We're still early on when the beans are much smaller. You can actually dig these plants up, and you should be able to see them on the roots. Now, I have pre-dug plants. I don't know if we'll find any females or cysts on here. Unfortunately, as they get older, they are less ideal for postal females, but I did actually find one. You guys want to take a look? So, in this finger, you'll see a little yellow dot on that root, and that is a female. So right where this index finger is, little yellow dot. Yep. Either way, they're very difficult to see. Earlier on, you can see a lot of them on these roots, but they're prolific, and they have multiple life cycles that will occur in a year. So their life cycle is about 30 days long. In that, summer, you can have multiple generations that are going through their life cycles, which means you can start at a very low population and end very high population. Vice versa, using resistant sources, or as we'll talk later, different seed treatments, you can sometimes see high populations decrease to lower populations as you use those products. So unfortunately, I don't have any hard and fast answers on how to fix this, but I can tell you that resistant sources in combination with seed treatments are one really good way to combat them along with crop rotation. With all that said, I do have a plot map of this. You're more than welcome to walk through and take a look at how these are doing, and I'm happy to answer any questions.
These are 2, 3.
Yeah, which?
2, 3. Yep.
Yep. So, yes, those are 2 3s. They were all planted in April, late April, April 27th specifically. We plant early in hopes that we'll also see, with our seed treatment trials, hopes that maybe we'll see SDS. We never end up seeing SDS, so it doesn't matter. I know, which is really good. That's a good thing. SDS and soybean cyst nematodes can go hand in hand. They can overwinter in the female cysts. They have sort of a symbiotic relationship. So the fact that we're only seeing the females and the cysts and not SDS is a good thing. We don't typically see a whole lot of SDS. We do see a lot of diaporthy symptoms, which can mimic SDS later. But any other questions?
What about freezing? I mean, like, cold weather doesn't affect them?
It does. But, so for example, in this field, we've had very, very high populations for the past 2, 3 years. And we had a really cold winter this past winter. And so we've noticed at 30 days, we come in and do soil samples from each plot. And then we also dig up 5 plants from each plot. And we actually will blast using like a hose all of the females off the roots. And then I have the pleasure of counting them. One of the things that myself and actually Jake Jones, who was our Kent County Extension agent for a while, he helped me. One thing that we noticed was that these populations were a lot lower this year, and that was reflected in our soil count. So weather can kill them. It's just that you can't control the weather, unfortunately. And with it getting hotter, with our temperatures rising, that does make it more difficult. Any other questions? So how they do against each other in this area. These other sources of resistance typically tend to do better in the Midwest. They haven't really made their way into the East Coast yet, but we're hopeful that we can see some soon.
Is that 188 same as Peking?
No.
No, 2 different resistance.
Yes, so Peking has one genetic resistance source that's very similar to the 88788, but it also has a second resistance source that 8878 doesn't have. So it has the 2 genes that'll help with resistance compared to the one.
Around the world, are there any other new genetics that contain natural resistance to the soybean cyst?
That is a very good question. If I'm honest, I'm not sure, but I can get back to you. I only did a master's, so I only had 2 years to study this. So I ended up focusing most of my research on what we can do here in the Mid-Atlantic, since that was where my focus was. But that is an excellent question. I personally would love to find out for you. Anything else?
Need rain here.
Yeah, we do. We've been trying to hold off on irrigation so that it wasn't muddy for everyone, but it's very dry today.
We're probably water Tuesday.
If I comment.
If you want, you're free to walk through these plots. I do have plot maps that you can take if you like. I also have these lovely resins that can show, it's a little bit harder now to see female cysts, but we have those as well.
Well, why haven't you considered including soil fumigation as a comparison to these other improvement methods?
Soil fumigation can be very expensive and labor intensive, and it's slowly kind of trending out, especially when you talk about resistant sources and seed treatments, which you can buy seeds that are already treated. You don't have to do anything for these resistant sources on the farmer's part, and that is more desirable. for most growers and save some money. So we haven't seen a lot. It's slowly kind of phasing out. Also with soil fumigation, a lot of the products that you're using typically tend to kill everything in the soil, including the SCN. And you don't really necessarily want that. You still want your beneficial microbes and things to help the plant. So that's kind of another risk assessment we have to make.
How many species are there?
Of nematodes?
Yes.
Oh, there's a lot.
So you have one chemical will kill the rest.
So the good news is a lot of nematicides will cover multiple species. So we have treated seed here. We use Saltro and Olivo. Those are both labeled for other species like root knot nematode and lesion nematode. I'll talk about those a little bit in my survey as well. But you'll see some of the same treatments we use here, you'll see over in our root knot field when we focus on root knot nematode as well.
The seed treatments only protect the plant when it's treated, soybean seed is treated for that season, or does it have any effect on later season establishment or multiple generations
Yeah.
of nematodes?
It is only for,
Short lasting?
yeah, it's short lasting. The benefit of using it though, what we've seen, so unfortunately a lot of nematode data isn't statistically significant, but we have a lot of observations that show anecdotally that it can make differences. You have higher yields at the end of the season for a number of reasons. But the thing that it does the best is it protects these soybeans as they come up for emergence. Not only do you have a higher percentage of emergence after planting, but you also seem to have lower on-root activity when using seed treatments. We did a seed treatment trial that Alyssa will talk about a little bit as well, and what we noticed is that we had lower female counts and lower soil counts in plots that had seed treatments. And so what we think is it helps protect that plant when it's most vulnerable, which is when it's early. It'll help protect it when it's early and it's most vulnerable. As they get older, they're less vulnerable to SCN, so that first 30 days is pretty critical. It helps them get out of the ground and get established.
Does that necessarily mean that a shorter season variety might be mid to late Q4?
I'm not sure. We haven't done a lot of work here specifically with seed treatments and say like double crops. A lot of it's just been long season beans. So I'm not sure, but it is an interesting question. There's still a lot of questions regarding nematode work.
Are there any long season varieties out here?
I mean, these are all your standard season varieties. So these are all typically in your mid to like late threes and some early fours. So they'll be here for a while. We probably won't harvest until October, sometimes November. So these little guys right here are the only ones that are short seasons. It was I know it was a typical race that you can find here. We did HG typing instead of races, and that's what helped us figure out what our reproduction levels were as well. So HG typing is it's a more modern way of looking at races. You can, to answer your question, HG type is important, but here we seem to have reproduction with multiple HG types of nematodes with multiple races, so it doesn't really seem to make a difference what we do. We just have soybean cyst nematodes across the board. HG typing is a way of classifying the type of SCN that you might have based on the plants that you have and the reproduction levels. The work that we've done with races here has been very, very limited.